Good morning, students. In this lecture, we are going to discuss about a PCD counter design using TQ flip-flop. Designing a PCD counter using T flip-flop. Right. Now, the T flip-flop characteristic equation is if you are applying, if you are having 0, no change. T value is 0, no change. And T value is 1 complement. No change, one complement, right? So 0 is if we are having that state is 0, then it will retain 0 itself. If state is already 1, it will retain 1 itself. If you are applying that 1, if state is 0, it will complement to 1. If state is already 1, then you are applying t1, then with clock, then it will go for that 0. It's a complement, right? So only 2. So 2 input, 0 input, then no change. 1 input, it will complement. So this is the characteristic equation of the T flip-flop. The character is not T flip-flop is already called toggle flip-flop. If you are applying 1, it will toggle, otherwise no change. Right. Now here this is a PCD counter. PCD counter is here, it will count 0 to 9 and then it will go for 0 and then 9. In this consecutively it will count 0 to 9, then 0, 0 to 9, right? So this is the sequence it will go for the sequential circuit. Now here initially we are having now all are 0, so that is 0. 0 by applying a clock it will go to 1. 0 to 1, right? Then next here from 1 to 2, the next step. Then 2 to 3, 3 to 4, 5 to 6, 6 to 7, 5 to 6, 6 to 7, the 7 to 8, 8 to 9, then 9 to it will go to 0. So here we are having Q8, Q4, Q2, Q. So instead of the ABCD, we can give the name as Q8, Q4, Q2, Q1, right? So this is weightage 8, 4, 2, 8, Q. So here present state, the next state is here, right? So from initially we are having 0. If you are applying clock, then it will go to 1. If 1, then 2, 2 to 3, like after 9, it will go to 0. So this is the case, right? Now here we are applying here, that one, right? Then here what we are having now as then another one, the output is here after completing that one, you are giving that one clock out. So that is here all are 0 at the final, that 9 to 0 to the 9 to 0, 10 count is over, then it will give now that output. This is used for the next digit, used for next. So here 9 to 0, then the next PCD counter is going to increment by 1. So for the increment by change to 1, right? So for that we can use the next stage clock, then we are having that one output is 1. Then here we are having now for transit, right? So 0 to 0 transit, there is no change. So input is 0. Then 0 to 0. So the change is only one the last bit. So we apply 1. Right? Like then here we have to fill the flip-flop input for the transit, right? So the transit from here 0 to 0. So the transit is 0 to 0. Then we are applying 0. 0 to 0, no change. Applying 0. Similarly, 0 to 0, no change. Now 0 to 1, so complement. So complement for that we apply 1. Similarly here, right? So the same one, you put 0. Then different one, you put 1. Right? So the corresponding one. So for example, the 9 to 1, 1 to 0. Then here 0 to 0, it's simply 0 to 0. The 1 to 0, right? So that one as here, 1 to 0 is conversion. So this is the conversion, right? So that is we are transit from 0 to 1 to 0, then 0 to 0, then 0 to 0, then 1 to 0. So here 0 to 0 we are applying 1. Sorry, we are applying 1 here, right? Then this is 0, this is 0, this is 1. Like we have to fill the table. So easily we can fill the table. We can fill the table properly, right? So this is filling. Then we have to go for the Karnaugh map. So here we take the TQ. For the TQ, we are having now that here the initial state, present state, right? 7. For the 7, we fill 1. For the 9, you fill 1. For the 9, we fill 1. So, one for TQ8, 1 as here only the 2 state. 2, right? So, that one as here, you are applying that one, right? So, that is 0, 0, 0, 7. So, this is the case. This is 1, then 9. 1, 0, 0, 1, 9. This is 1, right? Then this is 1. And here we are having now the tone care condition, right? So that is here 9. Then here in that 10, 9, 9. This is 9. The 10 is tone care. So then no 10 is coming now. Then 11 is tone care. Then 12 is tone care. Then 13 is tone care. 14 is tone care. And 15 is tone care. Right? Now here this is 1. So what we have to do is we are having now this is 1, right? So that is here 0, 1, 0, 7, right? For 7, 1, then here we are having for 9, 1, right? So here what we can do now, we can connect this one. So this pair we can take, and also here we can take this pair, right? So this is for that one we are having now Q8, the common is Q8. Here we are having now, here you can take this one as 4, right? 4 combination. Here you take is 4 combination, right? So that one is Q8, and here the common is Q1. So Q8 and Q1, Q8 and Q1, this is a pair. So in that pair we are having now, then here the common is Q4, Q2, Q1, Q4, Q2, Q1, Q4, Q2, Q1. So T8 we are getting now, right? Then here we are having now, we are getting now, right? Next one, this is for T8, TQ8. This is for TQ4. So Q4 is here. We are having on 3, 1, on 3, 1, and then on 7, 1. So 3 is here, 0, 0, 1, 1. 3 is 1 on 7. So that is here. The 7 is 1, right? So this is 0, 1, 1, 1. The 7 is 1. Then here the tone care condition is here from here to tone care, right? So 10, 10, 11, 12, 13, 14, 15, right? Now the combination is this one, this one is covered, and everything is covered now. So we are having Q2 and Q1. Q2 and so T4 is Q2 and Q1. T4 is Q2 and Q1. Next we are going to have TQ2. So here we are having 1, 1 as here 1, 3, 5, 7. 1, 3, 5, 7, right? So that is 1, 3, 5, 7. Right? 1, 3, 5, 7. And the don't care condition is here we are having now 10, 11, right? So 12, 13, 14, 15, right? Then all others are 0, 0. All others are 0, 0. Then here you can take this 4 as combination. This 4 as combination. So for this 4, we are getting now Q8 dash because of the 0, 0, Q8 dash, here Q4, both are 1, 1. Q8 is Q1. So Q8 dash Q1, Q8 dash Q1. Next for TQ1, all are 1. So directly you can apply 1. All are 1. Directly you can apply 1, right? Next one, Y is only that at the time of the Q8 as well as Q1. So you can directly write it as Q8, Q1. Because of this is the 1, right? So this is the 1 at the time of the 1001, right? So that is here 9. So 9 is 1, 9 is 1. Then here 10 is stone here, 11 is stone here, 10, 11 stone here. Then this is stone here, this is stone here, stone here, stone here. So this is the case, right? We are taking this one. This is actually Q8 is 1, 1, right? So Q8 is 1, 1 in that one, right? So that is here 1, 1. This is 1, 0. Here we are having now 0, 0, 0, 1, 1, 1, 1, 0. Q8 and Q1. So this is Q8 and this is Q1. So Q8, Q1 is Y output, right? Now you can draw the circuit. You can draw the circuit easily, right? So that is here we are having now T flip flop. You have to write and you have to draw that and arcade and something here you have to draw. We are having that equation and then you can draw the diagram, right? So that is here we are having now that 4 T flip flop. So this is one T flip flop. Sorry, escape. Correct? One T flip flop. Right. You make a copy. Escape. Okay. Control C. Control V. You take this one. Right. Next T flip flop. Control V. Next T flip flop. Control V. Next T flip flop. Right. So here you have to take in that whatever that order you want, right? So that is here TQ1. So escape. This is TQ1, right? TQ1 and 2. This is TQ2, TQ4 and TQ8. This is the input, right? Then here we are having clock. Okay, the clock is directly connected to the clock pulse, common clock pulse. So this is clock, right? So this is clock. Then here we are having the TQ, right? Then this is actually we are having Q output is Q1. Then this is Q8, Q2. This is Q4. Then this is Q8, Q8, right? So this is Q1 bar, Q1 bar. Then this is Q2 bar. This is Q4 bar. Then this is Q8 bar, right? Then here we are having TQ is directly connected with 1. So directly connected with VCC, directly with power supply. One is VCC. Then TQ does this Q8 does and Q1. 8 does and Q1, right? So you take that feedback of the you are getting now that feedback from Q1, right? You assume that one, the Q1 is feedback from here. So that is here, right? So that is here Q1 we are getting from this is the Q1 feedback, right? Then Q1 and then Q8 dash. So this is a Q8 dash, right? We have to connect with AND gate, connect with AND gate, and you have to connect it is here. TQ2. And TQ4 is Q2 and Q1. Q1 and Q2, right? So this is Q1. So we are taking now TQ4. You are taking that Q1 and we are taking now Q1 and Q2. Q2 here, right? So you take this one as one feedback. Q2 here. You take these two and connect with AND gate, and you have to connect then with the TQ4. Next, here we are having now TQ4, right? Next one is TQ8, right? So Q8 and Q1. So Q1 and Q8, Q8 is here, right? So that is here. Q8, you take now Q8 and Q1. Q1 is here, right? So this is Q1. So Q8 and Q1 connected and put it in a AND gate, right? Then Q4, Q2, Q1. So this is Q4, Q2, right? So Q4, Q2 and Q1. Q2 and Q1 is this one, right? So Q2 and Q1. Q2 and Q1 is this one. This is Q2 and Q1, right? So Q2 and Q1, then Q4. This is the Q4. So you take this one as this one you take as one input, and Q4 is another input, and you have to connect with AND gate. These two AND gate is connected with one OR gate, and put it into T8. So this is the equation T8. Right. So once again I'll draw that the wrong way I'm drawing. Right. Here just you take now. This is Q2, Q1, Q2, Q1 and Q2. This is sorry Q1 and Q2. They TQ4. Right. So Q1 and Q2 is this one. Q1 and Q2. This one is Q1 and Q2. So Q1 and Q2 you take, and then the Q4. Q4 also you have to take, and you put it in one AND gate. This is we are having now Q1 and Q2. This is Q4. So this is Q1, Q2. Q1, Q2 and Q4. So this is we connect with AND gate. So this is one AND gate, and this is from one another AND gate. Then these two AND is going to connect with OR gate. Because of the OR gate, you have to connect, right? So this is a plus. So you put it in OR gate, and we are getting now this one, right? So the Y is Q8 and Q1, right? So that is this is Q1 and this is Q8, right? So this Q8, and then you have to connect with Q1 and Q8, right? So this is connect with one AND gate. You are getting now this is Y. This is Y, right? So these are only Q1, Q2. So this is the T flip flop TQ1, TQ4, TQ4 and TQ8. So you have to draw the circuit properly because of that pad is not working properly. I have drawn is randomly, right? So this is the way you have to connect that circuit, and you have to place the circuit in proper location without overlapping. Then it will be clear, right? Some overlapping may come, so don't worry about that one. So you are having the line is going to connect with the proper location. That's all. Here this is the way of implementing the BCD counter using T flip-flop, right? This Y is used for the next BCD, right? So like we are having now 0 to 0, 0 to 99. Then the same one is repeated. This Y is going to connect with the, here we are having now that clock pulse. So this not clock pulse. So this is going to connect with the another PCD counter start. So here this is 0. So it will increment by this one, right? So otherwise this is the clock we are going to connect with the circuit. Then it will go for the PCD counter. So the counter, one PCD counter is 0 to 9. After that, then we are incrementing by the previous counter 1, right? So that is 19. So 0 to 9, then 10 to 19, and 19 to 20, 20 to 29, like that, this counter, right? So PCD counter, 2-digit PCD counter and PCD counter. This PCD counter change in that Y is going to start the, are going to give the count to PCD count input, right? So we are giving now, then it will continue the count, increment the count. So that is here. We are having 2-digit or 3-digit count also we can have now. PCD counter, PCD counter, PCD counter, 3 PCD counter. So you have to concatenate with that one. So we will get now 3-digit PCD counter also. So we can stop here. We will continue by next lecture.